We would be starting in a couple of minutes. Waiting for a few more participants to join. Well, it is already 7 p.m. So I guess we would like to start our program now. A formal good evening and welcome to all the members who have joined us today for this distinguished lecture program by Mr. Manoj Chakravorti. He needs no introduction. He is our President Emeritus and he's the driving force of the chapter. Today is a very special day. We are celebrating World Environment Day. Though we have dedicated a special day for this, but I feel that every day should be a celebration for the environment because the environment is our mother nature. And one day is not enough to thank our mothers. Just like we cannot pick out one day to thank our own mothers, in the same way, we cannot have just one day to thank our mother nature because she gives us in abundance. She gives us without discriminating. And we are ever so grateful for everything that we draw from her. However, today is a special day when we have to remember that although globalization, technology, advancement remain important issues, but somewhere, if at all, we have lagged behind towards our responsibility towards Mother Nature, probably today is mend on. As we proceed in this evening, my earnest request to all the members, kindly keep yourself in the mute mode and keep your videos off unless you are talking, as it disturbs the flow of the speaker. And since he is not able to connect with you on a physical form, this becomes very difficult for him to concentrate. I hope everybody is on the same page. I request, however, everybody to please participate very enthusiastically in the program and use the chat box very generously. We are, my backend team, the chapter backend team is very aggressively looking at all your chats, what you write there. And every single question, every point is going to be answered by a speaker. He's going to stay back to answer all your questions. Even after the program, if there is anything left, we would definitely like to take it on through emails or WhatsApp messages and whatever. Without much ado, let us start with a brief introduction of ISHRE. Although many of you know what ISHRE does, but we have a small video to give you a glimpse of all the activities across all the chapters that we are doing, and happy to share this with you while rest of the people also join. May I request my backend team, Mr. Siddharth, to kindly play the ISHRE video.
We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The Acrex exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to select student members for careers in HVAC and our industry at the ISHRE Job Junction. Young minds are made aware of the need for saving power, clean air and sustainability. The K-12 initiative of ISHRE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection and energy efficiency and conservation, to enter and explore the universe of the Indian HVACR industry. Log on to ishre.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRE.
Thank you for the back end for all the support. I request our chapter president, Mr. Manish Tiwari, for the welcome address.
Thank you, Nilanjana. Thank you. It's a pleasure always hearing from you. Good evening, friends. Welcome all to the World Environment Day celebrations continuing here at the ISHRE Kolkata chapter. I would like to take this opportunity to welcome one of those special personalities we at the ISHRE Kolkata chapter are proud to have amongst our midst. Manoj Chakravorti sir is an institution in himself, one of the founding members of the Kolkata chapter, and still full of energy and enthusiasm about each and every aspect of the society in general and the Kolkata chapter in particular. Needless to say, his enthusiasm was evident all over the Kolkata chapter's sapling length endeavor for the last 1 week. Thank you, sir, for showing us the way. Today's evening's distinguished lecture, The Green Building Concept and Green Tips for Various Premises, is a continuation of the celebration of this very important day. We have already had a wonderful event at 4 p.m. today evening, where our young members and children of our members showcased their talent. We also proudly presented our take in the sapling plantation drive, the Laksh 1000, so aptly envisaged by our national president, which we have completed by planting more than 300 saplings. I am sure that the society is as proud about our achievement as I am in announcing it. I am also sure that we together will take this pledge forward in the whole of the year ahead. So without delaying the proceedings any further, I would hand over the proceedings back to our President-elect, Ms. Nilanjana Mukherjee, to carry on the eventful evening forward. Welcome, Manoj Chakravorti, sir.
Thank you so much, Manish sir. It is very pleasant to note that I just saw the participants list, and we have Champakali ma'am also with us today from Mekon. She has been part of ISHRE 40 years program, and she was the chief guest over there. Very senior professional in the industry. I wholeheartedly welcome you, ma'am. Thank you for joining our program today. Can we have the backend play the Laksha video, which is the theme for this society year and has been populated and made very energetic for all the members. Let us get to know our theme, that is Laksha. Thank you very much again, my backend team, for the support you're constantly providing me. Already we have our speaker with us, and I would not like to take much time. We should be getting on with the program now. Our speaker does not need any introduction, just to make some of the new members who may have joined recently aware that Sir is an alumni of BESU, that is IIEST now, where we also have our student chapter. He is a presidential member, that is, he has been our past national president. He is the president emeritus of ISHRE Kolkata chapter, and he has very rich experience in the HVAC industry, almost on every segment. If I start with the introduction now, it would take at least 1 hour. So let us skip that and go straight towards our lecture for the day. I would request everybody to please be very interactive on the chat box, and sir will be very generous enough to answer all the questions that comes through. Before we start, a quick glimpse of the disclaimer slide. Thank you very much. Manoj sir, over to you. Sir, please unmute yourself.
Thank you, Niranjana, and good evening, everybody. Today really a special day for the entire fraternity of not only for ISHRE, I should say it is a fraternity, entire human being, for entire human being today. It is a very special day because it is a World Environmental Day. Actually, this world, and before I start my presentation, I will just take 2-3 minutes to talk about the World Environmental Day, because World Environmental Day, all on a sudden, and when we have started celebration, first thing, number one. Number two, why and when we have really very much concerned about the environment. And when we have concerned about the environment, what are the action plan we did? For answering this three, first of all, we started concern about the environment from the year, say, 1980s onwards. And we started feeling that, yes, the environmental parameters is gradually depleting. When we talk about the environment, it is not only for the air, water, soil. No, it is air, water, soil, demography, social social bondings, everything comes together and it forms the environment. And now in our part, it was actually that makes the entire ecosystem balanced. And when people or the scientists started feeling that this ecosystem is gradually becoming imbalanced, so they were very concerned, and all the steps to prevent this depletion took place. Now, today I will talk not only not the total environment, I will talk the green parameters, mainly for the various types of buildings or industries or various types of application. What are the green things? Before we go for that, I feel we should have some idea about the concept of green. What is now? Shall I request to put my slide? Start putting my slide. Yeah. Good. Is the concept of green building and this concept of green building and green tips for various premises. These various premises means we have the various application, various areas, like we have the hospital, we have the offices, even we have the data centers, we have the various industries. In everywhere, this concept of green will be applicable, and if we can apply these things successfully in every places, we can really, finally, we will become successful in implementing the concept. Next slide, please. Next slide. Now, basically, understanding of the word green. What is that? It is basically the quest of activity encompassing the concern for energy efficiency, environmental management, water management, renewable energy, waste management, and recycling. All these things are focused for the word green. When we talk about green, all these things comes into picture. Now, green ensures the resource conservation. Green ensures resource conservation, energy optimization, optimization of chemical usage, and effective waste management. Now, if I go for resource conservation, what is that? Any idea? It is resource conservation means where from we are getting water. We are getting water from the groundwater table. It is a resource we are getting. So we will have to conserve that water as much as possible. Soil. We will have to conserve the soil as much as possible so that we should not, our next generation or generation after that, they should not starve for water. They should not starve for soils, etc. So we should use it in a nice way so that maximum resources are kept. For that, what we should do, we should try to adopt many things. One of the things is the waste management. Say, our body also gives up a lot of waste, and this waste, if we can utilize it, and from this waste, if we can take out extract the usable portion, that itself is a waste management. Supposing from the waste water treatment plant,
Sir, you are muted. Sir, you got muted.
is it okay now? Can you hear me?
Yes, sir, it's fine now.
Now, green premises are those which are environmentally responsible, profitable, and healthy premises to live, work. It minimizes the waste at every stage during the construction and operation, resulting the lower cost. I think this part I've already told. I only want to elaborate this part is that green premises means it is ultimately a premises from where profit will come. Profit means all the time it's not directly the cash will come. No, indirect profit also will become in the premises. The people who will be there, they will be definitely living in an environment where they can give the more output. That means productivity of the manpower will increase. And this productivity of the manpower, while increasing, it will give rise to profit. Supposing cost of production, cost of building a premises, if we can control it, if we can control the waste, naturally the cost will come less and profit will become more. So for making the green areas, ultimate aims are those. One is if we can protect the environment. Protect environment means from the premises, if we don't discharge noxious gases, suppose, without any treatment, that is the protection of the environment. Say industry gives up all noxious gases. This premises, when they uses the diesel generator, that diesel generator also gives up some gases. And if these gases are not emitted to a area where environment will not be affected, then otherwise our environment also will not be protected. So we will have to take care about all those things, like wastewater from a building projects or for a premises, a housing premises. If the wastewater is not treated and discharged outside, naturally it will spoil the soil. So environment is affected. So in all cases, we have to take care. Next. Now, green building offers the following benefits. What I've told. What are those benefits? 30% to 40% reduction in the operating cost. I'm coming how? Green corporate image. Healthy and safety of the building occupants. Enhance occupants' comfort. Improve productivity of the occupants. Incorporates and latest technologies and techniques. Incorporate the best operational practices from day one. Now, 30 to 40% of the reduction in the operating cost. 40% reduction of the operating cost if we can select the systems which are energy efficient, automatically the energy cost or requirement of energy will come down. And once the requirement of energy will be coming down, so cost also will be coming down. You can take a note of it. Normally, these type of buildings which are coming up, say for an IT building, for a shopping mall, for hospitals, also you will find all these places, even for the data center also, the first fee, you will find the major cost, operational cost comes from the HVAC. It consumes energy around 55 to 60% of the total energy consumed by the building is on account of HVAC. So, selection of HVAC system and its equipment will play a very important role in reduction of cost. And these norms and standards which has come out now, if we follow that one, definitely we will able to reduce the total cost of 30 to 40%. Once a building is made or a premises is made green by a corporate or by a builder, naturally the image of that corporate or the builder or the group will go high, and even they can charge some additional money from the buyer because this additional money, buyer will not mind to pay the additional money because buyer will be spending less money in their day-to-day operational cost. Enhance the occupants control. That healthy and safety of the building occupants means the building should be healthy, means inside the indoor air qualities or indoor environmental quality. Broadly speaking, I will not tell indoor air quality. It is basically indoor environmental quality, where indoor air quality is a part. Apart from indoor air, we will have to take care about the lighting. We will also have to take care about the noise. So these three put together, we will be making the indoor environmental quality. And if we make the indoor environmental quality a conducive for the people, naturally that will enhance the building height and the building's name and fame. Then enhance occupant comfort, and this will in turn gives the occupants a lot of comfort. And once the occupants' comfort is there, once the all indoor air qualities are maintained, all the noise level as specified are maintained, lighting level are maintained, naturally the occupant will give their best effort, and in the process the productivity will increase. And how this can be done? This can only be done by incorporating the latest technologies, latest technological equipments, latest energy saving equipments, all has to be incorporated, and then this can be obtained. Now, incorporation and not only incorporating the best technologies and best equipment, that is not going to give the best result. We will also have to see that the operational practice are properly maintained, proper training has to be imparted, and naturally the people should maintain the equipments. They should able to understand the importance of the areas and importance of the technologies. Accordingly, they will be maintaining it from the day one. That will be giving the best result. Next. So with this, what is the basic objectives of the green building? Effort for reduction of building load. Now, when we talk about the building load, it is not only the structural and the civil materials load. It is the electrical load that plays a vital role. It is the mechanical, electrical, and plumbing load all together, that MEP loads. Our main objective is to reduce the total load. Now, supposing if we put some mechanical equipment on the terrace, and if we put the heaviest mechanical equipment on the terrace, which have got maximum static load as well as dynamic loading, then automatically to take care about the static and dynamic loading, we will have to make that concrete structures in such a way that it can take care. So building load also will be increased. So we will have to select the system or the equipment in such a way that at least for the equipment, minimum additional load on civil structural part used to take place, number one. Number two, it should not create a problem for the entire environment. It should not be a part of damaging the environment. Next is reduction of load allows the designer to select the smaller, less expensive HVAC equipment, resulting the cost savings. Now, I have used one word, less expensive HVAC equipment. This is actually, we always, as a designer, one should always aim at using the equipment or the system which costs less, because for all practical purposes, if the cost is become high, then it will not be sustainable. We will have to look for the sustainability. So for looking for the sustainability, we will have to know that cost should be less, but that does not mean that you will compromise with the technical requirement or energy requirement or some other service requirement. We should even, we can spend, in some cases, we can spend in certain applications some more money, and we can establish that now you are spending this much money and you are saving that much money on operation. So your return of investment is so and so. So if we can reduce the return of investment, that also means we are going for a system with less cost. Then proper understanding of the dynamic nature of the interaction of the building with environment, occupants, use of computers, simulation for energy modeling, optimization. Now, one of the main major objectives is, which normally we fail to do, we should focus more than that, because when we select a site or when a site is given and a building is started, people started planning a building, how many cases in our country, at least I can tell in our eastern region zone, how many cases proper simulation is done? Simulation means orientation, checking of the orientation of the building with respect to sun and all, because that gives a major impact as far as the environmental load is concerned. How many cases we made the windows? Windows means what is the finding of the predominant direction of the air. And if we can select the predominant direction of the air, and if we can make the building oriented in that way, we can get the better benefit as far as the heat dissipation. At the same time, we should see that heat should come infiltrate less, but more infiltration of light should be there in the building. So that can only be possible if the simulation of the building is done. Number two is, it is as far as the building is concerned. Now, the building will be there where lot of computers and lot of other electronic gadgets will be there. So we should also simulate the load of that. Once we can simulate the load of that and simulation of the building is done, then we can find out the HVAC requirement correctly. Whether we really need 1,000 tons or it is 600 tons or it is 800 tons. Even 1,000 tons and 800 tons makes a difference of 200 tons, minimum 200 kilowatt per hour. And if it operates for 10 hours, 2,000 kilowatt a day. Once your requirement is coming down, that means generation point, your requirement is coming down. So the power plant that generates megawatts of few million megawatts of power, that will be coming down. Once it comes down, that means the exhaust or the pollutants from the power plants, that also will be coming down, and it will protect the environment. Because normally you will find, I'm telling you one thing from my practical experience, because I was with the many industries for a long time, and their normal tendency of the owner is not to spend money on the equipment or the item which will not directly contribute into the productivity or the profit. Supposing air pollution or water pollution of equipments, mainly air pollution equipment, directly not gives any profit to the owner. So owners are not really willing to spend much money on air pollution equipment. And result is that our environment is getting spoiled. Although there are regulations by Ministry of Environment and Forest, there are regulations by Central Pollution Control Board. Those are only regulations. Monitoring of those things is not done correctly. I'm sorry to say, because I'm telling you, there are certain areas where sponge iron plants were there. They used to take in Raipur areas. They used to take the scrap from Vilai, and those were put in the smelting furnace, and they used to manufacture ingots. Now, lot of fumes used to go out. So I was told to design the bag house. I designed the bag house. I got my fees for designing the same, and I find that these are all installed. But again, when I went for another, I find most of the plants are not running. I asked them, your sponge iron plant is running, why your bag house is not running? No. So much of kilowatt of motor, if we run, it is unnecessarily expensive. When we got the information, when the pollution control board people will come, before that we run it. So this is the normal attitude. That means, why I have told this thing, although we talk much about green, in then stars and all these things, we told so many things, but actual awareness of the people is yet to come. If somebody is aware to protect the environment, he will not talk like this. I think things are clear to you. Then a reduction of load attributes the less power cost of power generation. It is already told. Proper understanding of the dynamic, this part is over. Next. So our objectives are now clear. Next slide. Now, role of energy modeling during the conceptual design. When a design concept is frozen, at that time energy modeling should be done. And here I have shown the approximate energy usage for a commercial building is how much, and for a residential building is how much. So we find commercial and residential building in both the cases, residential building may be around 50%, but commercial building, it is around 60%, and HVAC. So the major thrust at the concept stage we should put, and accordingly steps we should take so that my consumption of energy comes down, it is becoming less expensive, and finally it is sustainable, and environment is also protected. Sustainable, less energy consumed, if it is there, automatically environment protection will come. Next. There are a lot of certification bodies in India and abroad. These certification bodies has come from USA. USGBC first came, and then IGBC has from USGBC, IGBC has formed, REVA is formed. Now other things are also there like JM and all. Then there are many more agencies are coming up. And what are the rating points for this? There also you will find energy and atmosphere, you are getting 33. Innovation in design, you will get 6 points. Water efficiency, you will get 11 points. Indoor environmental quality, you will get 16 points. Material and resources, you will get 13 points. Location and transportation, you will get 16 points. Sustainability, you will get 10 points. Regional priority, you will get 4 points. And integrated process, you will get 1 point. Now, there are many things which you have understood and you know, but there are certain things I'm talking about: material and resources, location and transportation. Location and transportation, that is 16 points is there. Why this location and transportation has been given so much points? This is because location means when I'm to take the material from very distant places, I'm to carry it either by wagon, by train, or by trucks. Train, trucks, all runs by either electricity or fuels. That means I'm consuming, supposing if I get the material from a short distance places, there I will be consuming less energy on account of material transportation. So minimum is the material transportation. That means the distance is minimum, we will be getting more points. Location and transportation is a very important thing. Material and resources. This is also interlinked with material and transportation. So we should always try to design the equipment or design the building also in through by the material which are available locally. Say fire bricks. We can use fire bricks where if I find the fire bricks they are very close to our site. So we should try to utilize the material which are available locally as far as possible for construction, for usage, and for various purposes of operation. Sustainable sites is another important parameter, because sustainable site means the site which is, when a project location is chosen, there are various parameters which are looked into. One is that transportation, another is the natural resources, means water, availability of water, what is the population of the people, any habitation is there or not, is there any farmhouse or farming places where lot of agricultural products is there. We should avoid, we should not rather disturb the natural thing which is coming up, and there we should not go and set up an industry or set up a places. Now in lot of places we have seen, due to many reasons, I should not tell, but one thing I have seen in a lot of places in Calcutta or in and around Calcutta, due to some reason, industries were not running, so that industries were totally stopped and dismantled, that total industry, and the buildings has come up. So there may be some viability was there. That is the reason why our Central Pollution Control Board or State Pollution Control Board has approved, or they have got the sanction. Now, from those 35 points, if you can score 40 points, then your building will be simply certified building. Yes, it is a green building. If you want to get a certification, silver certification, then you will have to get 50 points. If you want to get gold certification, 60 points. If you want to get platinum certification, 80 points. And from energy point of view, there is another certification agency out there. They certify on star basis. 1 star, 2 star, 3 star, 4 star, 5 star. This star basis certification is normally done by DE. And it is a very simple thing. They will come to your premises. They have their norms. They will take the drawing from you. they will calculate what is the built-up area, and per built-up area, what should be the consumption, what this much square feet. That is their norms is there, and whatever way you come, whatever starts you can achieve through your system, because you will have to submit your electricity bill there, how much unit you have consumed, it is clearly written, and they take the area from the drawing and unit from the electricity bill, and then they give you the star rating. And for your information, I am telling, in India, first time 5-star rated shopping mall, it came in our place. That shopping mall is Avani shopping mall in Howrah. First time in India, 5-star rated shopping mall came. And they have maintained this rating consecutively for 4 years. After 5 years, of course, I do not have that data. And this was certified by BE, and at that time the director of BE was Dr. Mathur. He came and he handed over the certification. Incidentally, I was one of the designers for that. I designed the HVAC. That's why I knew all these things. Next. Now, this is more or less some concept about the green buildings, or what is green, what is the benefits of the greens, what is the objective of greens, all these things. Now, I will give some tips for 2 or 3 premises for various applications. For a green hospital, what should be done? For a green office, what should be done? For a green data center, what we should adopt. There are so many applications are there which we can also do, but I have only chosen these 3 for this 1 hour duration or this much short time. I cannot take many. Let us first talk about some green tips for a healthcare facilities. Now, for healthcare facilities, the primary mission is healing the patients and providing the facility for the accomplishment of the mission. That means the problem of the patient, main objective is to cure the patient. Healing the patient, all these things are the terms they use, but it is basically curing of a patient. There are various problems for various people. So all are patients, and whatever problem is there, that has to be cured. Encompassing various space types such as doctor's room, doesn't require any special infrastructure. Operation theater, that special infrastructures are required. The research and diagnostic center, specialized medical equipment required. So there are, in a healthcare, there are many spaces, and these every areas does not require the same type of condition. Area-wise, actually need-wise, requirements of temperature, requirements of cleanliness, requirements of humidity, requirements of fresh air, everything comes. So it is basically need-based. So we will have to identify those areas. What are the areas which need special attention? What are the areas which does not require special attention, but certain temperature and humidity shall be mentioned. It is certain areas are there where from the contagious air, contaminated air should not come out to other areas of the healthcare. Such areas we will have to design in some other way so that we should get rid of that contamination through air circulation. System must be flexible to accommodate the remodeling and changes to the delivery of health services. And it is very obvious, all the systems, all the layouts should be as far as possible flexible. Supposing today is my requirement, we all can understand that our hospitals, more hospitals were made before 2020 for COVID treatment. But lot of modifications were made in the hospitals for the COVID treatment. Lot of areas were made for the COVID treatment, and lot of protection and precautions were also taken so that that contaminated air should not come to the other drugs. The same hospital, COVID patients were also there, and the cardiologist patient was also there, and arthritis patient was also there, and dialysis also. So, activities, we should make it flexible because we were not knowing that COVID will come. So the hospital which were flexible, they spend a less and they can convert it to fast. And the hospital which was rather rigid, they had to dismantle certain things more and convert it into COVID-conducive areas. Then changes are driven by the advancement of the medical technology and practices. All these changes are basically driven by the medical technology and the practices. This requirement of basically, we the engineers, we are the engineers. We are not the technologists. In a hospital or healthcare, who is the technologist? Technologist is the doctors or the microbiologist or the virologist. They will tell what is their requirement. Accordingly, we have to engineer the space to satisfy their requirement. So they are the main person. Before we finalize anything, we should have a close interaction with these microbiologists or virologists or the doctors. They will come out with their requirement. And if we do not discuss this thing in advance, then what happens? At a later stage, we may have to change many things. We may have to augment many things unnecessarily, which spends money and delays the projects. Next. Then sustainable practices that are selected and need to be capable of changing with the changes in facilities. Then whatever we follow, we actually establish that should be sustainable. Sustainable means not only energy efficient. Sustainable means it should be easily accessible. Sustainable means it should be operation friendly. It should be maintenance friendly. So all this aspect has to be selected, thought of. And based on this, we will have to select the systems. Now, in some cases, we will find in lot of places, maintenance space is not given. And ultimately, why? Because initially hospital was meant for say 250 bedded. Now they have expanded it to 300 bedded or 350 bedded. Now hospital area remains same. And they cut down on the services. And in the process, maintenance or operation of the various service facilities suffers. So we should be very careful. We should always rise to the occasion and we should tell that this is the effect. If you do it, this is the effect. And tomorrow, if you are not in a position to maintain it properly, then you should not blame. And in the process, your patients also will be suffer. We should we should clearly indicate this thing without compromising. At least as a designer or as a contractor or as a supplier or as an institution, you are giving warning to the user from the very beginning that you should not do like this. Otherwise, you change your requirement. Adequate provision of access maintenance, this I have told. Then you will find in a lot of hospitals, I have also done in many places, which I hate, but I have to do. That means in a hospital, putting the air handling units, ceiling, on the ceiling, that means ceiling suspended, it is really a great, it's a nuisance. Because once the air handling units is put in the ceiling, above the ceiling, then can you say how many people will go and attend to the thing? How many guys will go and change or clean the filters? How many people will go and clean the coil? Nobody bothers. Only we do sometimes, but we give instruction, we give the access door also. But in actual cases, it is difficult. I should not blame the operator. So we should always try to have mainly the healthcare, the air handling units as far as possible with the accessible things, and it should be mainly on the floor mounted thing, so that with adequate space, so that one can easily go there, one can easily change the required consumables, and that actually gives a betterment for the hospital patients, and the objective of the hospital can be achieved. I will not name one of the very renowned nursing home of our Calcutta, where I went and they told me for some AQ planning, and when I went inside, I thought there is at least 20 millimeter thick dust is there all around the AQs. And that is one of the great, very renowned and costly nursing home of our city. I showed them. They told, oh, we are taking care. Anyway, this should be taken into mind, and we as a designer or practitioners, we should always caution the people. Usage of integrated design team, knowledge, experience, professionalism, minimum construction or execution, all these things basically is an integrated project planning. Means I am a HVAC person, I should also sit with the electrical and then low voltage guys, then compressed air guys, gas line, the guys in the hospital who is doing the gas line, all should see. And accordingly, they should finalize. They should see the requirement of everybody's requirement, and then they should do. Everybody's requirements are known to each other in a composite way or in a coordinated manner. It cannot be done. So for doing a thing in a coordinated manner, as well as to satisfy the requirement of the healthcare, we should see before we start planning. High performance strategies. This is the initial design brainstorming, what I have told. This is going to give us the very good performance, because once we know our routine, our part, and everybody knows their part, their portion, then there will not be any hindrance at the time of execution, And now there are a lot of softwares are available, and in this, if these softwares are applied, then the crash and other things we can get rid of those things, and that itself gives a very good savings to the owner. Because if we can determine the clashes in the drawing stages, and accordingly the drawings are prepared and clashes are detected and actions are taken, then automatically at site there will not be any material wastage. If the material wastage was 20%, that will at least come down to 3 to 5% only. That means there are a lot of savings. Next. Now, the safety and infection control. Now, safety and infection and energy, this I will put it in one way. There are in hospitals, there are a lot of areas. You can go through it, but I am telling you in general, in hospitals, there are a lot of areas. There are a lot of rooms where different types of patients are there. And each type of patients needs one environment, one condition. And that condition has to be made. In some area, we need sterile zone. In some area, we need normal. Wherever we need sterile zone, means we need a higher pressure. Means from the outside of that zone, air should not come inside. Air can go outside from that zone. Why? Because that is the critical areas. Outside, if it is a two-stage filtration, here there may be three-stage filtration. So why I will contaminate that area with the outside air? Accordingly, the pressure gradient as per requirement has to be made. And when we make the pressure gradient as per requirement, that means air quantity also will be changing. Changing of air quantity also will regulate the air handling unit's manpower. Unnecessarily, I will not pressurize the area. Operation theatre. There are some operation theatres where you require 25% of fresh air. If you put it, that is sufficient. There are some operation theatre where you need 100% fresh air. So earlier people used to tell OT 100% fresh air. 100% fresh air, we are spending a lot of energy. Isn't it? Our tonnage is going high. But now it has come, ASHRAE has come out with the findings and recommendation area-wise for a healthcare or hospital, what should be the various areas, what should be the condition, whether a positive patient is there, whether a negative pressure is there, all these things. A burn patient. If supposing a patient got burned, and if you start putting air at a high velocity on the body of a burned patient, he will not be feeling comfortable. So, a cardiologist patient, he may be requiring additional temperature, additional cooling, or he may be requiring a very calm and quiet weather, calm and quiet atmosphere inside the room. And doctors also want that he should go more and more sleeping. So even selection of air terminal devices, that also to be considered, considering the noise coefficient of those things. On that day, this room air distribution, our Mr. Krishnan had taken a elaborate discussion, and that is very important. Although people don't give much weightage, but it's a really very important thing. If we can distribute the air properly, not on a pocket, properly, then we can save energy also. In the area where cooling is not there, same quantity of air is going. We are not using the VFDs of the HU because we know that if we use VFD, extra cost. I mean, you may be spending some money, but with that money, it will work only as per load or as per requirements. Supposing a room does not have a patient, why to cool that room unnecessarily to say 25 or 24 degrees centigrade? We can only pass the ventilation air just to have the flash or exchange. We don't need. That means you are saving not only the HU fan, but also ultimately you are saving the chiller. How? If the requirement of HU comes down, automatically my chilled water requirement, then my across the coil, my in and out, that delta T will be coming out less, and that signal will be going to my chiller, and chiller will start bypassing. After secondary pump, it will start bypassing chilled water and more bypass chilled water and return chilled water when it will mix. Say my chiller in temperature is 12 degrees C and out temperature is 7 degrees C. Due to less load, my in temperature, if I can bypass the chiller and by chiller, the chilled water, then my load will, that my temperature will come down. If it comes down to 9 degrees, then chiller will start unloading and it will operate in the part load from 9 degree to 7 degree. So my chiller power consumption also will be coming down, plus my pumping cost also will be coming down because I don't need to pump that much of chilled water into the coil because my load has come down. So my chiller consumption has come down, my pump consumption has come down, and my AHU fan consumption has come down. So I am saving that much of energy. So we should always keep those things in mind, even if we want to save energy. Even say for where my 100% fresh air has to be used, I can take the fresh air, 100% fresh air. I can use the dedicated outside air system DOS. Maybe DOS initial cost is more, but that's saving a lot of power. So we'll have to apply in our mind and accordingly select the equipment and put it. And then it may be, say, a project where air conditioning may be a very percentage wise, it may be, say, today if it is 10% cost, a 100 crores project, say 10 crore is the air AC cost. And if you apply all these things, your 10 crore may be 10 crore 50 lakhs. So what is the total, in totality, 100 crore project, what is the increase? Nothing. But in the process, what you are getting, you are consuming, or you are consuming how much less of energy? You are creating a very conducive indoor environment as per requirement of the patient? You are making the indoor environmental quality as per requirement. That means most of the green tips, green areas you are covering. Plus, you can also go for recycling of wastewater, so that if you go with a water chiller, the cooling tower makeup, you can use it. So these are the basic things. This usage of resources. I'm just giving one example. In India, in what the industry, the Bharatiya Reserve Bank Note Mutual Limited in Shalboni and Mysore, they had used first time that much of huge recycled water for the air conditioning system, approximately 28 to 30 cubic meter per hour was the need of makeup water. And entire makeup water came from the sewage treatment plant. The sewage came from the township as well as from the shop. And it is a phenomenal saving, because that area there is no river water. That entire township and the plant that depends on the 5 borewells. And if one borewell goes out, that means entire production process will be jeopardized. And they have nicely planned the sewage treatment plant in such a way that means even after usage of cooling tower makeup, whatever spare water was there, that was used for the green belt development. So this type of mindset we should have for making the entire area green and energy efficient. Then provide redundancy of the equipment for fail-safe operation, because hospital is an important area, and we will put the proper redundancy so that what I'm saying, in the hospitals, many plants and trees are also put. We should be very careful in putting, because once we put those things, we should see that soil is not getting contaminated, and we should see that entire area is also not getting contaminated. Next. Energy consideration is basically hospital have an energy utilization index is about 2.5 times than that of the typical office building. Reduction of energy cost, this I that it is a very vital thing, because hospitals are mainly 24/7 operation. But one thing we must keep in mind, that hospital is 24/7 operation. At the same time, hospital load is varying up and down very fast. So while selecting the units, we should be very careful, because it should not be that unnecessarily for 1% of the time or 2% of the time we take a lot of equipment. Even we can adopt various technologies, so that in case of any exigencies or emergency, we need not suffer. We can think for thermal storage system. And that will give not only for this hospital exigency problem, but it also gives the less energy saving. So we should, as a designer, we should be very open that how much we can save and what is the trend, analysis of trend of the hospital, patients in and out, all these things, and where is the location, nearby any hospital is there or not, these parameters all we should think of, because those will be giving really the energy saving. Energy efficient system selection is very important, and this energy efficient system we should select because we will have to select. First thing, the most important selection is the system selection. And once we normally talk about the equipment's efficiency. Look, if you go as per the equipment efficiency nowadays, you will find a lot of equipment has come up to the efficiency level up to 90, 95%, 97%. So there is hardly much room for the improvement of the equipment design. But when you look at the system efficiency, you will find it is still between 75 to 80. It's very good. But that means in system design, system efficiency design, there is a lot of rooms still left, which will be giving a lot of savings of energy. This system or the system design, this encompasses the low side design. Air handling units onwards. Next. Ensure the systems are operating as intended. The design construction team needs to be functionally tested and proven all systems are operating for the intent, as per the intent. Real commitment to monitoring, benchmarking, having a continuous improvement process in places equally important and optimized. Now, this commitment of monitoring, benchmarking, it is a must. We may go nowadays. This monitoring has become very easy, or it is less problematic because of the incorporation of the building management systems. And this building management system gives a very good results for monitoring. Not only for monitoring, it gives a very good systems, gives a very good or easy controls. And it is also a software oriented. Supposing we have got 3 chillers. We have got 3 chillers, each of 300 tons, 300 tons, 300 tons. 900 ton plant, 300 tons. At one point of time, load has become 600 tons. Now, BMS will take the decision whether it will allow 2 chillers to operate, 300, 300, or 3 chillers to distribute into 900 tons. How? Because the software which will be fed, that will be fed along with the characteristics curve of the chiller. In that characteristics curve will give the chiller of at certain point of time or certain percentage of loading, it will give the maximum efficiency. With that logic, the software will select whether 2 or 3 or all chillers will run or 2 chillers will run. Because this will give finally the energy saving. So this part we should definitely incorporate in our design. We should rather explain in detail to clients. Sometimes they do not agree, but once the client is properly fed, they will definitely agree and they will follow the things. Because otherwise, this monitoring, manual monitoring, is never giving the correct results. Next. Occupants' comfort, I have told, it is basically the comfort of the patients. So this part has already covered. Next. Key elements of cost. Cost are the bottom line. Cost at the bottom line, yes, is the HEPA filter cost. The unnecessary HEPA filtration, wherever it is not required, we need not provide. Only where it is required, we should provide, because it is not only capital expenses. HEPA filter gives the cost for the operating expenses also, because these are the filters which are not renewable. It is a throwaway type filters. So we will have to use it where it is essential. And another is, putting a filter means you are putting additional resistance for the air path. That means your pressure of the fan will go high. That means fan motor also will be going high. So we will have to think both. But that doesn't mean we will compromise. No, we will be only using where it is required. Energy recovery strategies shall be assessed using the life cycle and energy saving vis-a-vis the control analysis. Next. Here, basically, there are certain areas are giving the following, provides general guidelines for maintenance of the noise, because noise is a very important parameter. And you know, when we are talking about IEQ, one of the derivatives is the noise. So this is the ASHRAE guideline about the noise. So this should be kept. Next. This is the suggested filtration and pressure cascading for various areas, what we should do, what we should follow. This is also the ASHRAE guidelines. So while designing the hospital, this is normally followed. Next. This is the various areas where the temperature and whether and relative humidity, whether it is positive or negative, all these things are clearly spelled out in this table. This table is also taken from the ASHRAE guidelines. And if any doubts or anything is there, you are welcome to ask. And if anything you feel you want to discuss, that also you can discuss it. Next. 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 This is another areas apart from hospital. I will just briefly tell. This is a data center which is very energy consuming area, and the most of the energy intensive building energy requirement varies between 20 watt per square feet to more than 1000 watt per square feet. That means the racks which are used now, earlier it was 2.5 kilowatt, 4 kilowatt, now it has gone up to 22 kilowatts. So supports its spaces, IT spaces, electronic equipments and electronic communication. Then HVAC system for the data center can be as diverse as the data center themselves, because there are various ways depending on the rack loads and rack disposition, the things are divided and things are done. Reliability and reliability of the infrastructure and IT system to minimize the risks and losses associated with the outages, along with the minimization of energy cost consumption. This is basically the various types of data centers are there. It means tier 1, tier 2, tier 3, tier 4, all these things. And accordingly, it is spelled out in their standard that what should be the reliability, how much, to what extent reliability should be there. Next. This is basically reliability, the same thing, install only the necessary redundancy to meet this. I told you T1, T2, T3, T4, in all these tires, that extent of redundancy is told, and this is not only it is told for the HVAC equipment, but also it is told for the electrical and all services. What should be the redundancy percentage, whether it is 33%, 25%, or 100%. All are spelled out very clearly. Next. Use air management practices, incorporation of monitoring and control equipment to measure the efficiency and performance of HVAC system, use of cooling plant, best practices, incorporation, chiller optimization, chilled water versus DX plant. All studies has to be made. Earlier, small data centers were there. We used to use the DX plant with the down discharge, and we used to take the underfloor chilled water, and we used to throw from the cold air from the bottom. That was the earlier perspective, but now the data center has become big, and it is not only chilled water system has also come, but in many places, racks are now coming up with the inbuilt air conditioner. It is a plug-in type. DX system is there, plug-in type. And it is, you can have air-cooled, you can have water-cooled also. For air-cooled, you will have to, only the condenser is located outside, and you will have to take the refrigerant pipes inside. And this piping will be going on. But that gives a very good efficiency also, and that has come out, and many companies like Cider, they are also doing this thing. Then another company which was very famous earlier, all these companies, they are also now making, but this is again for a large data center, these things will not be very much economical. Avoid high energy consuming humidity control such as reheat control or humidity using a dew point sensing considers alternatives such as the desiccant humidification, adiabatic humidifying, etc. Improving the distributing efficiency and and captured and reuse the waste heat whenever possible. Yes, that is a very good thing. Waste heat, and this waste heat, whenever possible, we can use it. But waste heat is maximum in industry. In industry, when data center is coming, and there we can utilize the waste heat, because industry, lot of waste heat in the form of steam and all is going out. So we can utilize the waste steam, and we can utilize this thing for even air conditioning, for the vapor absorption machines, where we can utilize the waste heat. And in Vizag, I think we have got one of the largest VAM machine or VAM plant, vapor absorption plant in Vizag, utilizing the this waste stream. I think in case Komal is here, Komal can tell what is the capacity, but it is very high capacity, and the machine was Mitsubishi's machine was there. So improvement of the distribution efficiencies, the capture and reuse of waste heat, and different. And waste heat, I am telling you, waste heat does not mean that you put a boiler, then use the vapor absorption machine. That is not correct. In Calcutta, one of the hotels as well as this Shriram market, they put the boiler and then use the VAM machine. After some time, they feel that for running the boiler, they need the fuel. Either then you need a coal-fired boiler or you need a fuel. So cost of that, and that is not really very much, not at all economical, because they are thinking that van machine doesn't have compressor, so its major cost, power cost will go high. That's fine. That is, you are saving. On the contrary, you are spending money on account of fuel for operating this plant, that boiler. So where you have steam requirement, or you can augment it, or when you have waste steam or waste heat, here you should try to use that waste heat, and then you should use for this van. That is most effective. Next, equipment of the servers with equipment, server virtualization where applicable, the collaborating department, the purchase. Now, for this, that is all we have considered. Is the control of HVAC system is basically the entire air conditions at the inlet, and different thing. Basically, in server, what happens? In server, you have got a lot of sensible heat. When the your racks are on, then you have got a lot of heats. Naturally, you are dealing with the sensible heat. But all the racks are not operating all the time. So there should be a good control that of the load. And accordingly, the air conditioning system also should operate. Why I am telling there are inbuilt system in some cases are very much effective, because these inbuilt system on the racks, as soon as the bank of racks operate the system AC, which is there, that automatically switched off. And when again the rack started, that system automatically starts. So your basic control, otherwise you will have to control that load, that whenever your load is going down, you are switching off, or your part load operation starts. Whenever load is going up, your part load operation is on. So that problem will be over. Now the key elements of cost is infrastructure redundancy, comes with the significant capital cost. This we have got nothing to say, because if we go for a tier 1, 2, 3, 4, there are certain norms spelled out. Accordingly, one has to go. So if that norm tells that you will have to have 33% redundancy, you will have to provide 33% redundancy, not only AC, for all electrical and other gadgets. Then incorporate the latest technologies for the handwires and infrastructure. That has to be done, because unless we go for the latest technology, we will not able to make the system environment friendly. Next. Now, this is another area which we have given some tips. That is the commercial buildings, the commercial office buildings, and are made up of primary office spaces, meeting rooms, that central core facilities such as toilets, rooms, storage space, etc. And high performance strategies are considered the dedicated outdoor air system DOS with the total energy recovery. That is here I have also got something to say, that not everywhere DOS will be required. Supposing if we go for a for radiant cooling system for our Calcutta, it is a very difficult, because in Calcutta it is a high humidity. So in radiant cooling system we can save energy. We can take the chilled water pipes either at the roof or at the floor level. It is better to take, if we take it at the floor levels, then my floor surface temperature, I will have to make it in such a point that it should be above the dew point temperature. If it is less than dew point temperature, then what will happen? We will have to induce the fresh air, and when the induction of fresh air will take place, and if it is humid, too much of moisture is there, then automatically condensation will be the result. So in such cases, we can assure of induction of fresh air through DOS, because we can get the outlet of the DOS humidity to the extent of 40%, 35%. So you are maintaining the temperature is also you are maintaining it, trying to maintaining above the dew point temperature and giving the fresh air in giving the fresh air in around 35-40% humidity, and that gives you that eliminates the total possibility of condensation. So that we should think, but if it is not in Calcutta, had it been in Delhi, then we need not go for DOS. There we can go for some other system for fresh air induction, because there it is not, humidity is not the main factor. Wherever the latent load is more, we can go, and we should aim at going that, say, if we go for a radiant cooling system, we should go and maintaining the surface temperature. If we maintain above dew point, means there is a possibility of any, what I should say, condensation eliminates, because there will be leakage. Some leakage used to take place from outside. So if the temperature is above dew points, no dews will be formed, no condensation will be formed. Next, occupational comfort, and system should be designed to appropriately comprehend the noise and occupied spaces. This I am again telling, not occupational comfort. When we are talking about, we should think of temperature, humidity, the noise level, and lighting control. All we should have, the daylight and views should be optimized, while the minimizing heating and cooling impact on the building. We should also consider the daylight as far as possible, so that my lighting load I can play. The key elements of cost is premium to be paid to the first cost of the energy conservation measures, avail the energy rebate programs wherever possible. Energy recovery and underfloor air distribution system gives lot of minimization, or lot of consumption is less, because normally in the office our cooling requirement comes up to, say, 6 feet level. Up to 6 feet level, above that cooling requirement is not there. So normally when we throw the air from the side or from the top, we throw it above 10 feet level. So from the 10 feet level, it is coming down to 6 feet and 6 feet below, 6 feet and below the 6 feet. Then our temperature increase is becoming more. Means if I put that temperature of air around 22 at that point, so when it will be coming to the occupant space, it will be around 23 or 24, or sometimes it may be 22 also, depending on the weather. But if I put it from the bottom, underside, what will happen? 22, if I put it, it will directly come, and gradually it will pick up it, and it will go in the return air circuit from the top. Now, when my exit air temperature is 16 degrees centigrade, and when my exit air temperature is 22 degrees centigrade, my coil chilled water temperature is also varying. Wherever it is 22 degrees centigrade, my chilled water temperature I am increasing. And whenever it is 15, 16 degree, I am using maybe 7 degree or 7.5 degrees centigrade. When my chilled water is 12 degrees centigrade, my load is coming down. Load is coming down means I am saving energy. But again, the cost factor is more. But we will have to give the calculation that even if we go with the radiant cooling system, this is my cost, and with this cost, my operating cost is reduced this much. So overall return on investment is this much. And in some places, hybrid ventilation is also hybrid with ventilation and air conditioning put together. But again, I am telling, this is possible only where it is not humid, it is a dry. Next. I think these are the three spaces I have considered. Other than these, industries are also there where we can use environmental friendly things like wastage, reuse of waste heat, wastewater, everything is very much. I have given an example for wastewater utilization for an industry. If we go to any steel industries, and I have given another for waste steel, that is for steel plant that our Vizag steel plant they have utilized, and this waste steel, because processed steel water where there is required in industry, lot of processed steel water are required. Then for processed steel water, big AC plants are required, and there we can utilize this one. Thank you very much. Now, if you have got any question, please feel free to ask.
Yes, sir, we have got a lot of questions in the chat box. So I request one by one, you can unmute yourself and ask your questions. Mr. Gautam Rai Chaudhary, if you are still present, you can unmute yourself and ask your questions. Mr. Gautam Rai Chaudhary, if you are present, you can ask your questions. If not, then we will move on to the next person. SN Bose, sir, you had two questions. Kindly unmute yourself and ask your question, sir.
One question I asked that about this 30 to 40% energy consumption, if there is some application where it can be seen. But of course, I am not sure whether Manoj will say, look, there is no requirement of basement ventilation because your car will be parked 1 kilometer away and you will come by a bicycle. So this way energy is saved. So one or two some salient features how this can be achieved. This was my first question.
Okay. I am telling Shubho, this is not basically, I have told this cost is basically the air conditioning portion. Now, selection of equipment means when we talk about the equipment selection, and that equipment selection comes what is the equipment we are selecting and what is the COP of the equipment or basic chiller we are selecting, whether we are selecting the proper BMS or not. Proper BMS means BMS control or not. It is not only the BMS mostly used for monitoring, but whether the control is also used or not. Where I have told one thing, where the chiller selection based on loading will be taken, decision will be taken by the software. In such cases, obviously, you will be incurring some cost, but capital cost, but your operating cost will definitely coming down, and with this, it will be definitely less. Number one. Number two is basic thing what we are told that normally in the design, very not in lot of projects I have found in mainly eastern region, if I tell you, that this type of simulation is never done. Simulation and selection of proper thing, proper glasses and proper wall materials and all these things is definitely going to reduce the cost to a great extent. Even the double wall or composite wall, if we make, that is going to reduce the load. I have seen in 1 lakh square feet area, the load has come very less. Load has come even to 1 lakh. I am talking about the air conditioning area. Load has come to 375 tons when using the composite wall and with the proper orientation. That means west facade we have not utilized. We have made glass area, we have reduced. In the facade where your maximum heat infiltration will be there. So all these parameters, when we put together, we will definitely save energy, save cost. Cost means I'm talking about energy cost to the extent of 30 to 40%.
Booster, you had a second question also.
Yeah.
You can ask the same.
Yeah. My second question was that this is possibly I have forgot this equation. This how this carbon credit and this green building is related actually. I mean, what is the carbon credit and how it is getting compensated or something like that? Actually, I forgot this. I learned long years back.
I am telling you,
meanwhile,
it is a very good question you have asked and it's very elaborate, but I'm just giving you a brief answer. I will send you, if you want that carbon credit, that how you can take it. But basic thing is, carbon credit, or now one of the latest thing has come, that building decarbonization. That means carbon credit you will be getting, and if you can reduce the consumption of energy, means ultimately for reduction of this much energy, this much power will be required to be minimum production of this much power will be minimized. So with that minimization, the emission of the power plants, that carbon emission will be less, and then you will be given the credit on account of carbon. That is the formula for that.
No, but how, now in that case, if I'm not mistaken, let me ask you another, this one in this context, that this is one we are talking about the power generation. So let us assume this is, of course, from fossil fuel, like what we say that coal, this thermal power plant, but or gas-based power plant, but it is not applicable for hydraulic or nuclear power plant. So, but that is one part of it. This is what we are talking about, generation of power. But at the consumption end, I mean, when we are talking about a green building and we are talking about a carbon credit, now what does it mean actually? If we reduce the consumption of energy in that particular building,
it is basically reduction of carbon footprints in the environment.
Okay.
One is basically reduction of carbon footprints in the environment, carbon content in the environment.
Manojda, if you allow whatever you said, can I just add few points to Shubhroda?
Yeah, we can.
Shubhroda, see, basically what Manojda said is absolutely correct. When you have, say, ASTRE standard 90.1 as your base for any particular type of building, say you take an IT park. So as per your base building consideration, suppose you are supposed to consume in a year 1 lakh unit of power. And through all your green building initiative and fantastic design and optimization, you demonstrate that you end up using, say, 80,000 units of power. Yes. Okay. Now, as Manojda said, there is the formula which says what is the cost of saving these 20,000 units of power, which is related to the average carbon which is emitted to generate those 20,000 unit of power, right? Now, suppose you have a facility in America. I'm just taking a name.
Yeah.
Now, America, a building is supposed to consume only 1 lakh unit of power, but they are ending up consuming 1,20,000 unit of power. So that fellow has to actually pay this amount of money to that IT park owner in India, and there is a carbon trading exchange which is there, which is supposed to mediate this. Correct. But if you remember, when we were, I'm not taking the name of the project for obvious reason. When we were doing the first core and shell gold rated as per USGBC building outside USA, you were very much a big participant to that project. These things we were trying to work out with Ernst and Young.
Right.
Remember? So
Yeah,
that is the fundamental concept. Now, this carbon trading exchange is still under a lot of, you can understand it is highly politically motivated and
that's
a
okay.
lot of power
That
are
is
there. But the basic concept is this, that if somebody is consuming more power, he has to pay to somebody else who is investing money and saving power. So that's the whole basic concept of carbon credit, trading in carbon credit.
Okay, this is in universe. This is maximum done in the European countries. Somebody is paying and somebody is receiving.
Right. Sorry, Manoj, for the interruption. Just because I had worked in one of the cases, I thought I will just add something.
Booster, your question is answered, right?
Yeah. Thank you.
Okay.
Thanks,
Meanwhile, we are going to the other participants also with their questions. We have posted a quiz in the chat box. Request everybody to kindly answer the quiz questions as fast as possible. Just 4 or 5 very small questions. Request everybody to please participate in the quiz. Kamal Sarkar, sir, you have your hand raised.
Yeah.
Yes, sir.
Hear it?
Yes, we are able to hear you, sir.
Manoj expressed that in the Vizag steel plant there is a waste heat recovery VAM machines. Install capacities, Manoj, there are in 2 different streams. One stream is for the captive power plants and another stream is from coke oven battery exhaust steam, because coke oven battery generates some amount of steam also after the power plant. That steam is taken again into the generation of running of the VAM machine, the condensate, low pressure steam. Now the installed capacity of the power plant with combined capacity is 8 into 1000 TR, and for coke oven battery, including 5 batteries, which has been recently commissioned by Mecon, so that includes 5 into 1000 TR. So altogether it is 13,000 TR installed capacity of the VAM machines.
Yes.
It is a huge capacity. And they are using these in tandem with their centrifugal machine based 10,000 TR combined vapor absorption machine, vapor compression machine. There is the overall network of the
I can remember the make. It was initially it was Mitsubishi's make.
Subsequently, their Thermax has supplied many.
Thermax after subsequently. Initially, Mitsubishi had supplied.
Actually, Thermax comes along with the power plant mainly in the power plant. And the Mitsubishi machine was particularly for the coke oven battery, which was originally built in the long back, 1 to 4.
That was long back. I'm telling you, it was in 89, 90.
Yes. That time I myself and Mr. Nagpal, we worked for that project, and it was basically it is being used for benzol recovery.
I am telling you, this was supplied by Blue Star and Mr. Prakash Rao. He was the guy who was at that time located as a branch manager, Hyderabad. He was the person involved in doing this.
Okay, thank you.
Thank you so much, Kamal sir, for that information. Mr. Roy Chaudhary, I see that you are present and you had 2 questions. Request yourself to please unmute now and you can ask your questions. Okay, I think he's again having issues with the connectivity. We go on to Mr. Abdullah Mamun. Mr. Mamun, if you are present, please ask your questions. Mr. Mamun, are you present? Okay, he is not present. He's not present. So, however, sir, his question was that what should be the filtration level post-COVID situation to keep the IOQ better?
Actually, this what should be the filtration level in the post-COVID? If you tell me, I will tell that all what we are talking about this is in general term, because this COVID virus, till now, microbiologist or virologist has not concluded worldwide. Unless they conclude worldwide about the virus, actual requirement cannot be told. But yes, two-stage filtration, that means even up to 95% down to 0.5 micron is adequate, because if you go with the sizes of the virus, what has been told, that can be arrested with this filtration.
Right. Sure, sir. Mr. Roy Chaudhary, are you back?
Hello, I am
Yes,
audible.
yes. Yes, you're audible now. Please ask your question.
Ajay, first question is this capital involvement for the desired economy, what we want to achieve on operational area. What is the extent of capital involvement to achieve that operational efficiency?
Operational area means any project
Yeah,
operational
no,
area.
you told, yeah, that 30 to 40% you mentioned in earlier.
I'm telling you, supposing if a normal area, costs say 1,000 rupees per square feet, this is hypothetical. I'm telling. Then if you go with this, it will be around 100,000, maybe 20%, maximum 20% more, not more than that.
No,
as far as the capital investment is concerned.
Yeah, capital investment vis-a-vis the operational efficiency. What you are
now
getting
operation means that
for achievement of grid building. Yeah,
and operational benefit will be 30 to 40%.
Yeah. To what extent is it feasible, viable?
It is definitely viable, but for all practical, it is for all practical purposes. If you tell, I will not tell 30 to 40%. This 10 to 20% increase, I will put it as 25%. And definitely, energy savings point of view, it is definitely 30% you can save. So overall, you will be in the positive, and whatever money you will be spending, you will be getting the return on investment within the span of 30 to 35 months.
Okay. Second question is, you have mentioned some credit rating, some nine parameters. Okay. That addition of these parameters and points allocated to each parameter, it amounts to 110 points, 110. Whereas this platinum building or gold building, whatever it may be, there you are allocating, assigning some points. Is it percentage or this is abstractly?
It is not percentage. It is not percentage. Actually, this is, if you go in the elaborate point rating system, there is some rating points for the core shell building. There is some rating point for the total building. And now there are certain things which are optional. There are certain things which are mandatory. So it is not a percentage. It is basically, there are certain things, it will be 100 point scale.
100, no, this is 110 I'm getting.
No, I am telling you, I am coming. You got 110, but there are some parameters which are not mandatory. So those are not optional. If you take the mandatory parameters, those are 100.
Okay. Third question, you are talking about the green building, okay, but how much progress India has made so far? Is it in concept or paper, or how much progress we have made so far?
Definitely on paper, we have really got advanced, and we have got a lot of areas to be done green. But to speak to you very frankly, I personally feel this green building revolution will definitely we can achieve once our full awareness will be there. Till now, we are not totally aware. Like this, I am telling you, in our house, when we leave a room, we used to switch off our fan. Do all the people in the office follow the same practice? I don't think so.
Actually,
this is a very basic thing. I am citing an example. So it will take some more time, because I am telling you, there are certain restriction or certain difficulties also. It is not USA. It is not Europe. It is in India. We will have to look it from the Indian perspective. Supposing today I have built up a 1 lakh square feet area, and while designing it, I have given it to Pratik the assumption that 50% per square feet basis you calculate the tonnage. So he does his things and he does everything perfect way. There is no problem. In India, what we will do when I will find that I have from one office, say X office has taken 10,000 square feet from me. I have given them at that time that your 50% per square feet should be the occupant. But that guy came with 20% per square feet basis. And he told me, if you agree with that, I will take your premises, otherwise not. But by this time, everything has been done. So again, some augmentation or some changes has to be made. And most of the builders, they get rid of by it's called just hand over it and I will just go from my perspective. So actually, if you talk about the green building perspective, how far we have achieved so far, I think we are yet to come to that stage, but it is for a country like India, we have achieved so far in a good way. There is no doubt about it because we have at least got good technology, we have at least got good equipment, and we have at least got good resources. But we have definitely gone ahead because everything what we are thinking very easy for other country, it is difficult for a country like India at this stage.
But as far as the building concept is concerned,
concept is definitely a practicable concept. It is not impossible concept. It is a practicable concept.
Okay, but it is our whole population to be covered, no?
That's why I told you for India we have to give some time.
Yeah.
And we have to give some time. That's why I told we will have to give
our population.
And main population and all. China has also got a lot of population, but they have gone ahead of us. The reason is very simple that our awareness we will have to bring it faster, and for bringing the awareness faster, we may require some good taskmaster.
But as far as the progress is concerned, have you achieved something? Or just
definitely we have achieved. Yes, we have achieved. Okay. We have achieved something. There is no doubt. Otherwise, this name green would have been erased by this time. We have achieved.
Okay, we have to move on to other people also.
No, thank you. Okay, thank you.
Mr. Avijit Sarkar, if you are present, please ask your question. Mr. Avijit Sarkar? Okay, I think he is not present. Sir, his question was, in various rooms in hospital, it is seen that recirculation is not allowed with room unit like FCU, ceiling suspended unit, etc. as per ASHRAE chart. Can we do recirculation with AHU having high grade filter and maintaining ACPH as per ASHRAE chart?
We can. Definitely we can make it, but only thing is that is again depending on the location. Supposing if one room location is one side, one end, other room location is other end, for these two rooms recirculation from a common HU will not be viable. So all things depends on the layout, and then but it can be done.
Mr. Prithvish Biswas, if you are present, you may unmute and ask your question. Yes, Mr. Biswas.
My question was in hospital barn. Hope I am audible.
You're audible. You're audible. Yes.
Yeah. My question in barn ward, if you give inputs in the HVAC aspect, how the filtration, how the air condition should be taken care, and isolation ward also.
normally in barn world, filtration level should be very high, number one. Temperature is not be very low, but it is again specified in that chart. But it is, and another thing, what has to be taken care, that is the air velocity through the surface. That means velocity should be a low velocity system.
And any more question, Mr. Biswas?
Okay, thank you.
Okay, yeah. Okay, fine. So we are done with all the questions, sir. And thank you so much for that excellent presentation. I hope all the members present have also answered the quiz that was posted in the chat box. And now we are towards the formal ending of this session. And I would request our chapter secretary, Mr. Shanko Bhattacharya, to kindly give the vote of thanks.
It's an honor to offer a vote of thanks on this occasion and on this World Environment Day. On behalf of ISRE Kolkata chapter and on behalf of the entire CWC team, I express a very hearty gratitude to our distinguished lecturer and our President Emeritus, Mr. Manoj Chakravorti, for his valuable time with us in today's webinar. We have been really fortunate to have him today in this program, who has been leading us from front and encouraging us from behind. Thanks to you, sir. I am thankful to all audiences, senior members, members and non-members, faculty and students for joining and attending this interesting and most relevant topic of the industry in this virtual mode. We are really privileged to have Madam Champakali Rai, Mr. Deepak Verma, Mr. Utpal Biswas, Mr. Anand Trivedi, Mr. Pratik Dattarai, Mr. Shubhronath Bose, and many other eminent HVAC personalities amongst the audiences. Thanks to all of you. It encourages us and other participants. I'm very thankful to Chapter President Mr. Manish Tiwari and President-elect Ms. Nilanjana Mukherjee for being with us and hosting the session. Thanks to our program chair, Mr. Amitabh Datta, and his team, Mr. Shubham Banik and Mr. Siddhartha Majumdar, and all who helped us either directly or indirectly to make this program a successful one. A special thanks to all our sponsors for their valuable contributions to the society. I take this opportunity and request all the non-members amongst the participants to come forward and enroll their names with ISRE and be a part of our society. Stay safe, stay healthy, and stay tuned to ISRE Kolkata chapter through various social media platforms for the upcoming activities and webinars. Thank you for being with us. Good night.
Thank you, everybody.
You can
Thank
carry
you,
on.
everybody. Thank you very much and take care.
Thanks to
Thank you, sir.
everybody.
Thank you.
Have a very good night, please.
Thank you. Good night.
Thank you.
I request backend team to please end the meeting.